You so much for the opportunity to join the conversation today. So my name is Matt Shields. I'm a senior offshore wind analyst at NREL. Yeah, apologies that I can't be there in person. Again, yeah, it's just great to be able to join the conversation here today. Just as a bit of background and why NREL and myself, located in the center of the country, are participating in an offshore wind talk in California. NREL has been involved in offshore wind for about 20 years, actually, at this point, starting with developing some of the engineering and high fidelity modeling tools that we need to just understand the new technology. And in recent years, getting more and more involved with the techno-economic and the wind resource and the social and environmental justice aspects of offshore wind. And really in the last 2 years, accelerating the work that we do on supply chain and ports and infrastructure and workforce and how that can manifest itself to support an offshore wind industry in the US. We've seen a lot of, and we've collaborated quite a bit with the Department of Energy at the federal level about some of the floating wind announcements that have been made in the last 6 months coming out of the Department of Energy. So there's been an Earthshot, which is a sort of an ambitious target set by the Department of Energy to reduce the cost of floating offshore wind by 70% by 2035. We've also seen the Department of Energy announce prizes to improve the serial manufacturing capabilities of offshore wind, to develop better mooring and anchoring design systems, and to start looking into a strategy for developing West Coast ports. And that's certainly very applicable to the California development pipeline. So I hope this isn't redundant, but just a couple of the things one of the reasons that we view floating offshore wind is so critical and so important is that floating offshore wind is about 2/3 of the resource in the US. So if we really want to take advantage of what the resource is over the whole country to contribute to our decarbonization goals, floating offshore wind has the opportunity to provide a really big part of that. And so California, with the lease auctions, which are happening tomorrow, and then potentially being some of the first commercial scale farms that are going to be built in the US, have the opportunity to really be a first mover and unlock this opportunity that we have in the US. Zooming in a little bit from the national scale, floating offshore wind has the opportunity to really support regional decarbonization with these local load centers on the coast. So you think about the big cities in California and the Bay Area or Los Angeles or so forth. The wind resource is tailored very nicely to when you have more demand for electricity. So there's a lot of benefits to creating those offshore wind generation assets, which can support that load when, for example, the sun is going down. It's a little bit harder to use solar. So there's a sort of a technical value to providing offshore wind. And as I think we all know, off the coast of California, the water gets deep so quickly that it really has to be floating in the region. In addition to the benefits of just creating offshore wind for the clean energy aspect of it, there's also a huge opportunity to create a local economy and local economic benefits that can ideally be designed in such a way to maximize benefits to all communities, not just the developers or the people that are building the projects themselves. I think to the comment in the last just a few minutes ago there, I think that understanding how these benefits and understanding potential drawbacks and how those fit throughout the range of interested stakeholders is a really important aspect. And taking things into account like this, both the technical side, the economic side, the inclusivity side, is really an opportunity for the US to be a thought leader in floating offshore wind around the whole world. Certainly fixed bottom offshore wind has been built in Europe, as well as in China and Asia and some other countries as well. But floating offshore wind has not been built at a commercial scale yet. So this is an opportunity to understand a whole new industry and how we can do it right from the beginning. So with that being said, there's still a lot of challenges that we have to address in order to get to this future state where we can be building these massive offshore wind projects, both sort of in an economically viable and equitable and sustainable manner. I think any challenge when we talk about floating offshore wind is just trying to convey the magnitude of how big these components are. We've really never had a component or never had an industry that couples the size of the components that are being built with the magnitude of them that actually have to get out the door in a reasonable time frame to make a project viable. Just for context, the floating platforms that these turbines are going to sit on are about the size of a baseball field. And when you put a turbine on top of them and tow it out to sea, it's going to be over 1,000 feet high at its tallest point. So I think the benchmark that we all like to use is that you basically can't assemble a turbine at the port of San Francisco because the Golden Gate Bridge is too short to let an assembled turbine get out the door. So that's kind of an indication of the scale here. The wind turbines in my background are tiny relative to the offshore wind turbines that would be built off the coast of California. The technology itself remains a challenge. As I mentioned, this sort of commercial scale project for floating wind hasn't been built in the world yet. We certainly got some demonstration projects, and we're learning a lot from these sort of activities. But that being said, when you start to talk about a project where you may have dozens, 50 or 100 floating wind turbines in the same location, you need to understand how this floating environment can drive the behavior of the different turbines, of the wind resource itself. Some of the technology we need doesn't exist yet, such as the cables that we would need to transport the electricity back to shore, at least the floating cables that we would need. And understanding the risk. Again, if you've got all of these different systems in place in the same location, how do you design it in such a way that that you're confident that you're not going to lose one turbine and have a sort of set of cascading failures through the wind farm. I think some other challenges include the port infrastructure and the supply chain. So we've heard already from Humboldt and from Commissioner Bass there, or Supervisor Bass. And Humboldt's doing great work developing their port resources for the offshore wind industry, but it's just not going to be enough. I mean, if we really want to build sort of the 25 gigawatts by 2045 that California is thinking of, that's going to require multiple ports in multiple regions. We need manufacturing ports, we need integration ports, we need service ports. So these are all a challenge in terms of the long lead time, the permitting, the costs that need to be considered when you build these up. But there's also an opportunity to create benefits, to create jobs, and be able to create, again, this local industry within the state. When we talk about things like a local industry, that sort of inherently means we need to consider the trade-offs between domestic and international manufacturing and supply chains. To what extent do we want to import components from overseas versus building them locally? This has I think there's naturally a cost impact through these, whereas we also need to consider things like the total amount of emissions that it might take to tow components across the Atlantic and the Pacific, and then maybe the different environmental regulations or considerations in the other countries that we might be manufacturing components in. So I think this really leads me to the point that we need to have sort of these holistic and interdisciplinary designs. You can't just design a floating offshore wind farm from an engineering standpoint and then start taking the design to different stakeholders and retrofit in the considerations of environmental groups or tribes or fisheries or whatever it is. I think that it's really important to have these holistic designs that are developed from the beginning that take into account these different perspectives. And understanding how all those different stakeholders have an equal voice at the table is a really important step that the floating wind industry is going to try to take over the next decade. And again, this really gives us an opportunity to be a global leader in floating offshore wind within the country. I'll just wrap up. I think I'm short on time, but just to summarize here about where the industry needs to go over the next few years to accomplish some of these things. Obviously, the lease sales tomorrow are super exciting. We've been tracking this for a long time, and we're very excited to see what's going to happen there. For anyone who didn't follow it, on some of the lease sales that took place earlier this year on the East Coast, an individual lease in the New York Bight region fetched over $1 billion, which went into the Treasury coffers to just to gain control of the site. The way that BOEM has structured these auctions in California is that there's essentially it's called a multi-factor auction or a bidding credit, which means that effectively some percentage of that funding is going to be dedicated to supply chain investments and workforce training in the state. So there's a mechanism for basically creating some of these benefits locally. With that funding, that partial funding mechanism in mind, I think that some of the next steps also include developing strategic plans for the supply chain, for ports, for transmission, which was mentioned earlier as well. We need to understand the role that each community can play. So again, to point towards Humboldt, this is a community that's had interest in offshore wind and has taken some first steps. Other counties or municipalities may be less interested, and I think that's something that needs to be taken into account. We can't impose a port on a community that doesn't want it. So the goal would be to work with local communities to improve outreach, to improve inclusivity, to share best practices from one location to another about how to really have this equitable set of voices at the table, and then invest appropriately in these sort of these resources. So some of this will be state funding, some will be private funding. There's a lot of different mechanisms that need to be considered here. Then there needs to be a clear sort of understanding of the supply and demand. So if we're going to meet certain offshore wind deployment targets, what does that mean in terms of the number of ports that we need, or where those ports should go? So the AB 525 legislation in California is a really good start to this. The NREL is also leading a port study to look at the whole West Coast to understand some similar questions of how the port network could develop, where Oregon, California, and Washington are kind of working together. This is an opportunity to learn some lessons from the fixed bottom community on the East Coast, where there's been quite a bit of sort of competition between states. There's fewer states on the West Coast, so that might make it a little bit easier, but it's important to understand what individual communities can do and how to build off those local strengths. I don't want to go into the details of the technology advancement, which is also important, but there's lots of technical work that needs to be done to get floating offshore wind to the point that it needs to be cost effective and efficiently built and delivered, and can again draw on the resources of the existing West Coast states and port communities. An example of this would be NREL is leading a study to look at how, if you take into account environmental considerations at the beginning of the design process, how that could change your mooring and anchoring design for a commercial scale offshore wind farm, again, as opposed to just designing the farm and then bringing it to stakeholders later and telling them that you've already made your decision. Just to conclude, I would say that this is a real challenge, and that we need to kind of balance our urgent need to decarbonize our economy and to create floating offshore wind and other clean generation tools that can reduce our carbon footprint, but also to conduct a thorough outreach and develop a sustainable supply chain that can put us in a good position to continue to build over the next few decades in a way that maximizes benefits to local communities and minimizes harm to these different groups. So it's a huge challenge. The communications that we're sort of seeing today with these type of groups, and the engagement through the various agencies in California is, I think, a really important step. The next steps are just going to be continuing to grow those relationships, to try to make sure the right voices are at the table, and to learn as we go through the development of this industry and just continue getting better. So thanks very much for the opportunity to talk, and I'll just conclude my comments right now.